I couldn't contain my excitement without thanking you. My eternal gratitude to all my viewers. And without your support, my journey couldn't be possible. Once again, thank you, and I would like to welcome you all formally for my next topic, that is on homogeneous differential equations from differential equations of first order and first degree. And also, don't forget to thumbs up and leave a comment below after listening and learning from this video. And let's get into today's problems. So those are from homogeneous differential equations. Both are of different kind. And the first one here is we have to solve x squared plus y squared dx is equal to 2xy into dy. And the next one here is 1 plus e power x by y into dx plus e power x by y into 1 minus x by y into dy is equal to 0. So both are equally important here. First I'm giving the solution for the first question here. So here, first of all, after looking at this problem, so we have to recognize that they are equally distributed variables. So there are two variables here, and also two variables here. So everything are equal, and therefore we have to construct this equation as a homogeneous differential equation. So here for homogeneous differential equation, generally we take dy by dx. So here is dy, and under this I am writing dx. Therefore, in the solution, see here in the solution, I am considering dy by dx value as. So dy, and I am sending this dx down, and therefore 2xy to this side. So x square plus y square by this value is 2xy. As usual, so for every homogeneous differential equation, I'll put y is equal to vx. So if I make a derivative, so this is dy by dx value is equal to, for x it is 1, so v into 1, and again I am leaving x here. For v it is dv by dx. See here, this is the substitution which I am going to use. So this is the substitution, and this is considered as equation 1, and this is equation 2. Now substitute the two value in equation 1. So here dy by dx here value will be, so dy by dx value will be, this is x square plus y square by this value is 2xy. So in place of dy by dx I am substituting this one, that is v plus this value is x into dv by dx value, and here is x square, and see now in place of v I am writing vx. So in place of y I am writing vx whole square by, see here, by this value is 2x times of, so this is 2x times of, again there is y here, I am putting so y as vx. So this is the substitution which we have to use in equation 1. And now let's calculate this one. So this will be v plus x into, this is dv by dx value is equal to, this value is x square. So if I make a square, this will be v square into x square divided by, this is 2x square into v. So if you can observe, there is x square here, there is x square here, and x square here. I'll take x square common and cancel. The next step here is v plus x into, this is dv by dx. If I take x square common, then this will be 1 plus v square by, here if I take x square common, this will be 2v. So if I cancel these two, and again if I send this plus v to other side, so if I send this plus v to other side, see what happens here. So this will be x into dv by dx value is equal to, this is 1 plus v square by 2v minus v. Again if I take 2v as LCM, so here x into, this is dv by dx. If I take 2v LCM, this will be 1 plus v square minus 2v square. So here this is x into dv by dx value is equal to, this is 1 minus v square by the value here is 2v. And next what I am going to do is variables separables. So I am separating the variables. I am sending v to one side and x to one side. Here is dv, I am sending this 2v to dv. So this is 2v by 1 minus v square into dv, and I am sending this x to other side, that is dx, and here there is x here. So here variables separables method. So after separating the variables, now I am going to integrate on both sides. So here is the integration on both sides. If I integrate on both sides, see here, The derivative of 1 is 0, and for v square it is 2v, and there is no minus here. So I am keeping minus. So this is of the form 1 by x into dx. So for v square this is 2v dv. So there is a derivative. I am writing it as minus of log. This is 1 minus v square, and here if you observe, so 1 by x dx is nothing but this value is log x plus this is log c. So if I send it to other side, so this will be log of 1 minus v square plus this value is log x, which is equal to log c. So you can take log c on either sides. If there is a minus, if you multiply with minus also, it's a constant value. Log a plus log b can be written as log a into b. That is 1 minus v square into x is equal to this value is log c. So if I cancel log on both sides, this is 1 minus v square into x is equal to c. So here is a substitution that we have taken, a substitution that y is equal to, see here, y is equal to vx. So for y is equal to vx, so what is a v value? V value will be y by x. So now I am going to substitute in place of v as y by x. So this will be 1 by, this is y by x whole square into x, which is equal to c. So this will be 1 minus y square by x square into x is equal to c. So if I take x square common, this will be x square minus y square into x is equal to c. So if I cancel 1x and send this x to other side, so this will be x square minus y square is equal to c into x. So here, so we got a final result as x square minus y square is equal to cx, and this is the solution. So here this is the solution for a homogeneous differential equation after substituting y is equal to vx. Hope everybody understand this one. Put y is equal to vx, and here in place of dy by dx as this one. So here after cancelling x square common and sending v to other side, and see here after that variables and separables and integrating on both sides, we got the final answer as this. And the next question here, the second question is also so important here. Every time there is no substitution of put y is equal to vx, sometimes we have to check. So here I have said you one logic here in my first question, that is, if the variables are uniformly distributed, identify it as an homogeneous differential equation. Here if you observe, there is a constant one here and there is something here. So how to recognize it's a homogeneous differential equation? See, first of all, if you look at this fraction, so there shouldn't be any fractions here. So in order to eliminate the fractions, what is the substitution needed? See here, there is an x by y fraction. In order to eliminate the fraction, so we have to keep in place of x as vy, and there is y here, and obviously it got cancelled and the fraction is removed. So that is the logic which we have to use in this. So this is the second type of question. So in homogeneous differential equation, one is put y is equal to vx, and in this question the variables are not uniformly distributed and therefore they need some substitution. And how to remember that substitution? So in order to eliminate the fractions, here is the substitution which we have to put, that x is equal to vy. So here for x is equal to vy substitution, so we need dx by dy. So here in the solution, so here in the solution I am sending this part to other side. So 1 plus e power, this is x by y into dx is equal to minus e power, this is x by y into 1 minus x by y into dy. So here I need dx by dy this time. Here is a substitution that I am taking x as vy now. So here I have to put dx by dy, and therefore dx by dy value, dx by, this is dy value is equal to, this is minus, this is e power x by y, 1 minus x by y divided by, I'm sending this to other side, that is 1 plus e power, this is x by y. And now the substitution here is put x is equal to vy. So here if I make a derivative, that is dx with respect to dy, for y it is 1, and if I leave y, this will be dv by, this value is dy. So here are the substitution. So here if I substitute this one, in equation 1. So this is equation 2 and this value is equation 1. So 2 in 1, if I keep the values of 2 in equation 1, see what happens here. So here is the substitution. So this one is a substitution. In place of dy by dx, I am writing, see, in place of dy by dx, I am writing, this is v plus y into, this is dv by dy, which is equal to, this is minus e power. In place of x, I am keeping vy by y. So this is y into 1 minus, in place of x, I am keeping vy. Clear? Vy are next divided by, so this is 1 plus e power. In place of x, I am keeping vy. Clear? Now if I cancel this y, so the fraction got cancelled. And see what remained here. This is v plus y into, this is dv by dy, value is equal to minus, so this is minus here, minus e power v times of 1 minus, this is v by here, this is 1 plus e power v. Clear? And now if I send this v to other side, then see what happens. So here if I send this v to other side, that is y into, this is dv by dy is equal to, this is minus e power v, 1 minus v by 1 plus e power v, this is minus v. And therefore y into, this is dv by dy value is equal to, this is 1 plus e power v. So if I multiply, this is minus e power v, this is minus into minus plus v into e power v. If I multiply, this is minus, if I multiply, this is v into e power v. So here if you see, I can cancel these two terms. If I cancel these two terms, what remains here? So this value will be y into dv by dy value is equal to minus e power v minus v by 1 plus, this is e power v. So here if I use variables as separables, so if I send, so here if I send v to one side, so here is dv, if I send this to the numerator, this will be 1 plus ev divided by, so if I send this one, this will be minus of, this is v plus e power v into dv, and if I send dy to other side, this will be dy by y. So this is dy by y here. So this value is dy by y, and after separating the variables, and now we have to integrate on both sides. So after integrating on both sides, see here what remains here. So it is so easy. So this is 1 plus e power v into dv value by, this is v plus e power v, which is equal to minus, this value is dy by y. So here for v, the derivative is 1 into dv. For e power v, the derivative here is e power v into dv. So the numerator, the derivative of the denominator is on the numerator. So this is, if you feel it's an x, it is dx. So 1 by x value will be log x. So here is the x value, that is v plus e power v is equal to minus, this is log y plus this value is log c. So if I send it inside, so this value will be log of, this is v plus e power v plus this value is log y, which is equal to, this is log c. Log a in plus log b value is log a into b, that is v plus, this is e power v into y is equal to, the value here is log c. So here if I cancel log on both sides, this will be v into e power v into y is equal to c. So here we made a substitution, that is x is equal to vy, and what is our v here? So v value will be x by y. So in place of v, I am going to substitute x by y plus e power, this is x by y into y is equal to c. So here if I take y LCM, this will be x plus y times of e power x by y into y is equal to c. Now if I cancel this y on both sides, that is x plus y into e power x by value is equal to c. So this is the final solution for the given homogeneous differential equation. So this is the solution for the homogeneous differential equation. And here, this is how we have to solve. Thank you so much for watching and staying till the end. If you really like this video, please pass it on to as many friends as you can, because they also needed the help from you. And thank you for staying till the end, and please watch the playlist. So many solutions are given for the different problems, and different formulas are also taught. Thank you so much for watching.